Welcome to this explainer. Today, we're tackling what might just be the absolute ultimate paradox of our time. It's one of those massive, complex puzzles that literally keeps economists, environmentalists, and policymakers up at night. Because, we all want a prosperous world, right? A world free from poverty. But we also desperately need a habitable planet to live on. So, are these two goals just fundamentally at odds? Well, stick around because we're going to explore a really fascinating framework that actually promises to solve this exact dilemma. I want you to really think about this for a second. Must economic growth destroy the environment? For decades, it kind of seemed like the answer was an unavoidable yes. I mean, think about developing nations today. Are they just doomed to choose between building their wealth and industrializing their economies, or maintaining a clean, safe environment? It feels like a totally impossible choice. If you want to lift millions out of poverty, do you just have to accept that your skies are going to turn gray and your rivers will run toxic? To see this paradox in action, we just need to look at this startling comparison. Back in 2007, China's gross domestic product, its main economic engine, was absolutely roaring at a massive 11.4% growth rate. That is incredible, undeniable economic progress that lifted countless people right into the middle class. But on the other side of the ledger, well, by 2006, China had become the world's absolute biggest greenhouse gas emitter. They were pumping out over 6 trillion, and yeah, that's trillion with a T, metric tons of CO2, pushing right past the United States' 5.975 trillion. It's the ultimate paradox, right? The exact same engine that creates life-changing wealth simultaneously fuels a massive international environmental crisis. Okay, let's dive into this. Here is our roadmap for today. 1. The growth versus pollution paradox. 2. The green solo model. 3. Technology to the rescue. 4. Testing the theory in China. 5. The resource depletion twist. And finally, number 6, can we grow sustainably? Let's get into it. Part 1. The growth versus pollution paradox. The high cost of development. So, we're dealing with a really high-stakes conflict here. Developing countries absolutely need industrialization. People need jobs, they need infrastructure, and they need a real escape from poverty. But on the flip side, we have this pressing global necessity to cap carbon emissions before climate change hits catastrophic tipping points. To ground this rather abstract problem in a very real, very tangible industry, think about this massive statistic. In China, the power generation sector alone accounts for 54% of the country's national carbon emissions, more than half. Just to put that into perspective, more than half of the carbon footprint of the world's largest emitter comes from literally just keeping the lights on and keeping factories running. It shows you just how deeply intertwined economic output and environmental degradation really are. Part 2. Enter the green solo model, a theoretical solution. Economics is often called the dismal science. And honestly, looking at those pollution numbers, you can easily see why. But we're going to shift gears now to a highly optimistic theoretical framework. This was introduced by researchers William Brock and Scott Taylor. They basically took a classic economic foundation and gave it a crucial modern update. So what exactly is the green solo model? Well, it's a theoretical framework that beautifully integrates environmental considerations right into traditional economic growth models. And I don't want you to think of this as just dry math on a chalkboard. Think of it as a powerful conceptual lens. What Brock and Taylor proved theoretically is that balanced, sustainable growth is actually possible. We aren't doomed. If we invest wisely and prioritize the right kind of technological progress, we can keep growing our economies while keeping our emissions at a stable, safe level. So, the absolutely crucial point here is how this model maps out a nation's life cycle. It predicts something called the Environmental Kuznets Curve, or EKC for short. Just picture a giant hump shape on a graph. According to this concept, when a nation starts developing, pollution goes up right alongside economic growth. They build factories, they burn coal, things get dirty. It's inevitable. But as the nation gets wealthier, it hits a turning point. Advanced wealth allows the society to actually afford better technology and environmental cleanup. So eventually, pollution declines, even as wealth continues to rise. The green solo model basically explains exactly how and why we can force that curve to trend downwards. Part 3. Technology to the rescue. Two types of capital. All right, let's pop the hood on this model. How does it actually function within a specific industry? The secret ingredient here is technology, and more specifically, how we choose to spend our money. To understand the math without getting bogged down in dense equations, let's use a clear visual metaphor: the tale of two capitals. On one side, you've got production capital. This is the investment in making things faster and more efficiently, like building the power plants and buying the massive turbines. It makes goods, but it creates emissions. It's the capital that dirties the air. Then, on the other side, you have abatement capital. This is the money dedicated specifically to removing and cleaning up those emissions. Think scrubbers on smokestacks or high-tech carbon capture. The green solo model shows that if technological progress in abatement outpaces the growth of production, we win. It's that simple. We get sustainable growth. Part 4. Testing Theory in China. The Power Sector Case Study. Let's step out of the ivory tower and bring this right down to earth. Researchers Zhenyu Zhang and Karina Schoengold tested this exact theory, using China's semi-regulated electricity generation industry as their case study. They mapped out what economists call a joint production function. See, in China's power sector, you can't just magically create electricity out of thin air. Electricity and carbon emissions are jointly produced. You put capital and fossil fuels in, and you get power and pollution out. The flow of emissions is just a direct byproduct of the firm's operations. So the researchers wanted to know, what kind of policy instrument, like an emission fee or carbon tax, would be required to stabilize the environment without completely crushing the economy? Now, what's really interesting here is this massive sudden drop, 16 plunging all the way down to 5. This isn't just some random statistic. This represents a huge drop in the required carbon tax needed to keep emissions stable. But what exactly caused this drop? It all comes back to that abatement capital we talked about a minute ago. The researchers found that the level of tax required to stabilize emissions depends hugely on how efficient your cleanup technology is. When abatement technology improves from just removing 10% of the emissions flow to removing 30%, the required emission tax literally plummets from 16 yuan to just 5 yuan per ton of emissions. I mean, that's an absolute game changer. It proves that investing heavily in abatement technology makes carbon regulation economically feasible for developing nations. You don't have to bankrupt the energy sector with taxes if you just give them the right technological tools to clean up their act. Part 5. The Resource Depletion Twist, a counterintuitive scale effect. This brings us to a fascinating addition to this whole theoretical landscape. A researcher named Rachel C. Reyes took the green solo model and added a very real-world constraint. She asked, what happens when we start running out of finite natural resources? Let's walk through how this builds a really surprising logical chain. Step 1, our finite natural resources inevitably begin to deplete. We have less easily accessible coal, oil, or gas. Step 2, because those resources are scarcer, the overall growth of economic output naturally starts to slow down. It acts as a physical limit on production. And finally, step 3, because economic output is slower, the growth of our emissions is also slower. Reyes summarized this major paradox perfectly. She noted, the positive impact of the depletion of natural resources in reducing the growth rate of emissions in the balanced growth path. It's completely counterintuitive, isn't it? Running out of natural resources is a bad thing for unchecked economic expansion. It physically limits our growth. But that very limitation acts as an automatic brake on environmental destruction. The planet effectively forces a slowdown, which helps stabilize our emissions. Actually, scratch that. It's more like a built-in safety valve in the economic machine. Though, ironically, it's probably not the safety valve we actively want to trigger first.
Part 6. Can we grow sustainably? The final verdict. Bringing all these concepts together, from that hump-shaped Kuznets curve to the sheer power of abatement capital and the hard limits of natural resources, we have to ask our original question: can we actually grow sustainably? Well, the models say yes, but definitely with conditions. The Green SOLOW model proves that if our technological progress in cleaning up pollution grows faster than our production, we can absolutely achieve that holy grail of balanced, sustainable growth. And the data from China shows that making those technological leaps drastically lowers the economic pain of carbon taxes. But as we just saw, we're still playing a really complex game with a planet made of finite resources. So I'm going to leave you with this to ponder. Technology can save us, and models prove sustainable growth is mathematically possible. But as we race to build all these amazing green technologies, at what cost to our remaining natural resources? It's a delicate, intricate balance, and honestly, finding that equilibrium is the true challenge of our generation. Thank you so much for joining me for this explainer, and as always, keep questioning the world.